right, 10.3c, operations with radical expressions. The last day of 10.3 here today, operations with radical expressions. We're going to simplify them, and we're going to use conjugates, which is a new term that you're maybe not quite familiar with, but we will get familiar with it. So operations with radical expressions, continuing on with that. So when we talk about rationalizing the denominator, again, remember, you've got a couple things that means. Remember, that means the method to eliminate all radicals from the denominator. Remember back in 10.2, we talked about how you cannot have a square root sign in the denominator of a fraction or any type of radical, so we had to do something to get rid of it. So here's a little review from that. If you had the 8/3 here, well, first I would rewrite it as the square root of 8 over the square root of 3. And then from there, remember, we couldn't have this square root of 3 in the denominator, so we would multiply the top and the bottom by the square root of 3. Multiply numerator and denominator by your denominator, and that kind of clears out that denominator, because on the top, you would have 8 times 3, square root of 8 times the square root of 3, which is the square root of 24. And then the bottom, you'd have the square root of 3 times the square root of 3, which is the square root of 9. So remember to keep your square roots with you. And then we know that on the bottom, it's pretty simple. We know that the square root of 9 turns into to 3. And on the top, on the numerator, we can break down that 24 a little bit more as well. We can go perfect squares and say square root of 4 times the square root of 6. And then we know, of course, that square root of 4 becomes a 2, so it would be 2 times the square root of 6 over 3 would be your answer there. Remember, that's getting rid of a radical in the denominator. But what if we have a situation where the denominator is not just one radical, as in this case, but all radicals? What if there's more than one? Or what if there's more than one term? Okay, what if it's a binomial down there? Okay, so what we end up doing is using a conjugate. Okay, so what is the conjugate? Well, we use these to rationalize the denominator with a binomial. So a binomial is 2 terms, remember. So if it's square root of 6 plus 4, or a good example here would be like, say we have 2 plus the square root of 2. Okay, well, that is a binomial, and it's got a radical in it, so we can get rid of it using a conjugate. And we're going to multiply, same thing we did with the last example. We're going to multiply the numerator and denominator by the conjugate of the denominator. Okay, and what is the conjugate? It's basically its form. It's the same terms, but the opposite sign. Same terms, opposite sign. So if I take this whole thing down here for my example, the conjugate here would be 2 minus the square root of 2. Okay? So we have the same terms, 2 and square root of 2, but instead of a plus sign here, we've got a minus sign. Okay? So that would be the conjugate. All right. So let's just do another example of what the conjugate would be. Let's say it's 3 times the square root of 2 plus 5 times the square root of 7. Let's say that was our term. Then our conjugate here would be 3 times the square root of 2 minus 5 times the square root of 7. So it's just the same terms, but just change that sign in the middle from positive to negative, or from negative to positive, whatever happens. Okay? Let's get into some examples using conjugates. All right. Again, just to remember, when you're rationalizing a denominator, that means you're getting rid of the square roots, getting rid of the radical signs. You multiply the numerator and denominator by the conjugate of the denominator. And yes, you'll need to FOIL. Okay, so let's look at example A here. So we've got 2 over 6 minus the square root of 3. So we're going to multiply the top and bottom by the conjugate, numerator and denominator by the conjugate. So we know that the conjugate is 6 plus the square root of 3. We're going to multiply that as a denominator. We're also going to multiply it as a numerator. But you have to do that because that together is a fraction, is 1. Because the same thing being divided by itself is 1. So we're allowed to do that because it doesn't change anything because you're multiplying by 1. All right. So let's just look at the top. So I'm going to just kind of put a screen down here, and just because I think sometimes this helps because you might get confused if you see all the other things that go on. But just look at the top first.
Excuse me, but at this time, will you please relieve the queue?
Hoop girls gone to the cafeteria today. Okay, so let's just do the top together, and just so that way you don't get confused with seeing all the stuff on the bottom as well. So we're going to distribute here. 2 times 6, that gives us 12, and then 2 times the square root of 3 is basically just 2 times the square root of 3. And so we've got it's a plus sign. So we're going sign, number, and then radical. That's basically what we're looking at. So that's the numerator, 12 plus the 2 times the square root of 3. Okay? So now let's look at, say, the denominator, if we do that. Okay, we'll look at just this part here. Okay? So in this case, I'm going to, not only am I foiling, but I'm actually I'm not only distributing, but I'm actually foiling here. So I'm going to go first term times first term. 6 times 6 gives us 36. And then we've got 6 times square root of 3. Well, if there's a positive, so I'm going to go sign, number is 6, and then radical square root of 3. And now I have to use the other one as well. So I've got the negative, the other term, negative square root of 3 times 6. Well, you've got a negative sign, so it's a negative, number 6, radical square root of 3. And then finally, we've got the square root of 3 times the square root of 3. Well, one's positive, one's negative, so I know it's going to make it a negative. And then square root of 3 times the square root of 3 is the square root of 9. Okay, so now let's look at some things that we can cancel out right away. First, those two middle terms, you've got a plus 6 times the square root of 3 and a minus 6 times the square root of 3. And those two cancel out. And that's why we use that conjugate. That's why the conjugate's important, because your middle term will always cancel out, therefore you have no radicals. Plus, the one over here is going to be a perfect square on the right side. We know that that can become a 3. So now in your denominator, you just have a simple math problem of 36 minus 3, which we all know is 33. And now I can get rid of the shade to bring down our numerator. Our numerator, remember, was up here, 12 plus 2 times the square root of 3. So that would be our final answer. We can't do any other reducing, so we're in good shape there. Okay, let's do another example. Let's look at letter D here. And I added letter E. No, I don't know if it's on your notes or not, but letter E is on there, so we can work on that at a different time as well. But let's do D. I want to get one more example. So you've got D, 2 times the square root of 3 over 4 plus the square root of 3. So again, I'm going to multiply by the conjugate. And the conjugate is the same terms of the denominator, just different sign. So 4 minus the square root of 3. But remember, I have to do that to the numerator as well. Okay? So again, let's just go ahead and I'm going to shade it just to avoid confusion. So the numerator is simply a distributive property. 2 times the square root of 3 times 4. Well, remember, we can multiply those numbers outside of the radical. So 4 times 2 is 8. This is 8. And then we have the times the square root of 3 as well. And then we're going to go 2 times the square root of 3 times negative square root of 3. Well, we got a negative sign in there. Negative times a positive is a negative, so we're going to go sign. And now our number, it's basically 2 times 1, because there would be a 1 in front of here. So negative 2. Let's see here. Hold on. So now we're going to have a 2 on the outside, and then square root of 3 times the square root of 3 is the square root of 9. So that is basically our numerator. And we can clean that up further because we know that the square root of 9 is 3. And so we're going to have to multiply that 3 and this 2 up here. We'll do that in a second. Okay, let's look at the denominator now. Use this. All right, our denominator. And we won't have to use the shade every time. It just kind of helps us to separate some things. Okay, so we're going to FOIL this one. So 4 times 4 is 16. Then 4 times negative 3 is given. We got a positive times a negative, so we're going to have sign is negative. 4 is our number. A radical is 3. And remember, now we do the second term times the first term here, and we'll get a positive 4 times the square root of 3. Remember, we go sign, number, then radical. And that's how it should work out. You got opposite signs there. And then square root of 3 times a negative square root of 3. One's positive, negative, so we have a negative square root of 9. If we can clean some of that up as well. We know that these middle terms will cancel out because one's positive, one's negative. That's how the conjugates work. And this also is a perfect square. So we'd have the squared, we'd have 3. So now I really have 16 minus 3. Well, this negative is gone because the whole term is gone, which is 13. Okay? So our numerator is up at the top. Let's combine them now. We've got our numerator up here is 8 times the square root of 3 minus 6. Okay? Because we have to multiply this 3 up here times this 2. And so it's 8 times the square root of 3 minus 6 all over 13 would be our final answer. Okay? So very similar to what we've done in the past. We're just kind of connecting on it. And then here's our lesson summary. When you have a binomial with radicals in the denominator, how do you get rid of them? So just a simple answer based on what we did today. And then we want you to simplify this one, 3 over 2 plus the square root of 2. Okay? So that is your lesson today. And we will see you next time.